All right, today we are going to learn about our last transformation, and it's called rotations. So we have talked about dilations, where we either have an enlargement or a reduction, following kx, ky, so where k is our scale factor, and that's using multiplication with both our x and our y original coordinate. We've talked about translations, where when we take a picture, maybe a rectangle, and we're sliding it on our graph. So we can take our picture and we're either sliding it vertically up and down, or sliding it horizontally left or right, or doing both. And that's where we're either adding or subtracting to our original x and our original y. Then we've talked about reflection, where we have the x-axis or the y-axis as our mirror image or a reflection over. So if this triangle were here and would reflect across the x, it's still the same distance from the right from the origin, but it's at a different height. So when we reflect across the x, remember that our x stays the same and our y's are different. If we were to use this y-axis for this triangle and fold this over, reflect across the y, it's at the same height, but now it's not to the right of the origin, it's to the left. So when you reflect across the y, your y's stay the same, your x's change. So just to kind of sum up all these rules we've looked at. So now we're going to see about rotations. So this video link here, if you haven't already watched it, it's going to be basically what I'm talking about right now as well, but just another way to see it, just if it helps you out, okay? So what our coordinate rules look very different. So we have x, y, and that's going to be our original ordered pairs. But first, we're going to switch my y and my x switch spots. So my original y, whatever that was, is now my new x value, and my original x is now the opposite, because remember that negative doesn't necessarily mean negative, it means opposite. It's now going to be my new y for this part. And we're going to talk about clockwise and counterclockwise. So these are your 3 rotation rules, and we're going to describe it after we graph it and kind of use what we know with these pictures. Again, what I'm doing here is explained in this video too, so if you need to hear it from a different person's point of view, you're welcome to watch both. Then the second rotation rule, x, y, well, my x and y are staying in the same position, but now they're the opposite, and they're both the opposite. So up here, only my original x changed, and now I'm having both my original x and my original y change. Then we have, okay, well, here's my original ordered pairs. Well, if it looks like this, where now my original y is now the opposite, and it's where my x was, and now my original x is where the y is. So a silly way that I kind of remember it, these two, your y and your x flip, and your x, your original x changes before your original y. And I'm going to tell you what that means over here in just a little bit. Okay, so let's look at our coordinate rules, and we have these ordered pairs. So what I've drawn on my graph is a flag. So I'm going to say when x is 0, y is 0. When x is 2, y is 4. When x is 3, y is 6. When x is 4, y is 4. So we're going to see how we're going to rotate this, think about turning something, and see what happens with it, okay? So if you were to think about it, if I had my phone right here, even how it has the time and that statue, if I were to turn it like this, that picture is not facing the same way anymore. If I were to keep turning, that picture is continuing to rotate and turn, and it's facing a different position. So kind of keep that in mind, okay? So let's look at that. So if I'm turning this, I'm going to say that this is a flag, and I'm turning it, it's going to be facing a different direction. So let's see what we're going to do. So the first color I'm going to use, just to kind of help me out, is this blue color. So I'm going to describe this first rotation. So x, y, so when x is 0, y is 0. Well, I'm going to switch, so this 0, which was my y, is now x, and this 0, which was my x, is now y, even though they're the same number. But the only thing with this, if we're doing the opposite, but the opposite of 0 is 0. So that one's just going to stay at 0, 0. All right, so let's see, x, y. X was 2, y was 4. I'm going to switch them, so y, my original y, is now x, and my original x, but I want the opposite. So that's my new ordered pair for that. Okay, so we're going to switch them again. So my original y, which was 6, is now my x. My original x is now my y, but it's the opposite, so I'm going to say -3. Okay, so basically you're switching your y and your x, and your original x is going to be the opposite. Okay, so if you need to pause the video or rewind that to hear it again, go ahead and do that. All we're doing is we're flipping our x and our y. They're changing spots, and your original x is now where your y is, and they're the opposite. So 2, -2, 3, -3, 4, -4. Okay, so now we're going to graph that. So 0, 0 is already on my graph. 4, -2, so 1, 2, 3, 4, down 2. Then my next ordered pair, start back at the origin, 6, -3, 1, 2, 3, 4, 5, 6, down 3, 1, 2, 3. And then I'm going to go start back at the origin and go 4, -4, 1, 2, 3, 4, 1, 2, 3, 4. But stop and think about it. If this was like a flagpole on the flag, and I rotate it like this, that means this line is going to be right here, and there's my flag right here. Okay, so the triangle has turned right here, and we have those two lines are perpendicular. So that is going to the right, and how we read time, that is a 90-degree clockwise rotation. So if you have a 90-degree clockwise rotation, you're taking your y and your x, and they're flipping spots, and you're changing your original x. Okay? Let's keep going. All right, so now they're saying if I have my original x and y, they're staying in the same position, but now I'm taking the opposite of both numbers. Okay? So again, that negative doesn't necessarily mean a negative, it just means the opposite. Well, 0, 0, they're staying in the same position, but the opposite of 0 is 0, the opposite of 0 is 0. Okay? So my original ordered pair, 2, 4. So my new ordered pair, x and y stay in the same position, but they're both the opposite, so now it's -2, -4. My next ordered pair is 3, 6. They're staying in the same position, but that negative means the opposite. So now I have -3, -6. And lastly, 4, 4, the opposite of both is -4. Okay? So those are what I'm going to plot down here in green. We're going to see what's happening. All right, so 0, 0. It's my origin already, so it's already there. So I'm going to go -2, 1, 2, and then 4 down. 1, 2, 3, 4. Then I'm going to start back at the origin and go 3 to the left. 1, 2, 3. -6. 1, 2, 3, 4, 5, 6. Start back at the origin again and go 4. 1, 2, 3, 4. Down 4. 1, 2, 3, 4. Again, think about this. Let me show you with my ruler, kind of help you out. If this is the pole right here of that flag, and it's rotating and rotating, well, now it's going to be like that. So we're going to connect these dots, and now my flag has rotated again. So if I went this way and made a right angle, and then from here to here I make another right angle, well, from here to here is another 90 degrees. Well, from my original starting point, 90 plus 90 is 180. So that is a 180 degree clockwise rotation. Okay, let's stop and think about it. We have 4 quadrants. Quadrant 1, 2, 3, 4. If I say that this is a right angle, this is another right angle, this is another right angle, this is another right angle, each quadrant, if you think about it, is 90 degrees. So if I rotate from quadrant 1 to quadrant 4, that's 90 degrees. From quadrant 4 to quadrant 3, that's another 90 degrees. So kind of makes sense when you think about it that way. All right, let's look at this third rule. The third rule is very similar to the first rule. You're taking your original x and your y, they're flipping spots, but now we're changing the original y. So the opposite of the original y is now going to be in the new x spot. Okay? So 0 and 0, if I flip them, they're still 0. The opposite of that 0 is still 0. All right, so 2, 4 was my original. So I'm going to change the order and say 4, 2. But my y was my 4. Now that's going to be the opposite of negative 4. Okay, so 3, 6. Again, they're going to flip. So 6, 3. But now my original y is the opposite. Okay. And my y was 4. It's now what x was. So those are my new ordered pairs. Okay. And then I'm going to teach you kind of a little strategy that helps me to remember these, because you are going to have to memorize these rotation rules. So let's graph these first. So we have the origin, 0, 0. Now we're going to negative 4, 1, 2, 3, 4, up 2. Back at the origin, negative 6, positive 3, 1, 2, 3, 4, 5, 6, 1, 2, 3. And then we also have this next one, which is negative 4, 1, 2, 3, 4, up 4, 1, 2, 3, 4. Okay? And if we think about this, let me show you with this picture. If we have rotated from here to here and there to there, well, this line, think about it like this. It goes one more time, so the line's going to be right here, and here's my flag. So we went one more time. So if I went from quadrant 1 all the way to quadrant 2 clockwise, I'm going 1, 2, 3 times. 190 times 3 is 270 degrees, and that's clockwise. Okay, so if you think about a clock from 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, from 12 all the way around is clockwise. Okay, so a couple things here before we move on. So if we went clockwise, I just write CW for clockwise. Let's think about if we can go another way. Well, I could have started here at quadrant 1 and gone one rotation 90 degrees clockwise, or I could have gone 1, 2, 3 times in this direction. So if I went 3 times right there, well, 90 plus 90 plus 90, or 90 times 3, is 270 degrees counterclockwise. So the rules for 90 degrees clockwise are the same as 270 degrees clockwise. Okay? Well, let's look at 180. If you started your original picture right here, and I went 2 times to the right, or 2 quadrants, 90 times 2 is 180. Well, 1, 2 times to the left is still 180. So 180 degrees clockwise is actually the same thing as 180 degrees counterclockwise. Okay, so your rules are the same. Then for that last one, I could have gone 1, 2, 3 rotations to the right clockwise, or I could have just gone 1 rotation to the left like that. And if I went 1 rotation to the left, that's just 90 degrees counterclockwise. Okay? So we just kind of put some things on there. Counterclockwise. I just abbreviated it. Okay? So here's the thing. It is a little intense because you have to memorize these. So let me kind of tell you a trick of how I remember it. We usually do clockwise before we do counterclockwise, because counter means kind of like the opposite, right? So you have to know your clockwise rules before you know your counterclockwise. Then my other thing I think of it is you have to count to 90 before you count to 180, before you count to 270. Well, the 180 rule is the same either way. Your x and y stay in the same spot. They're both just the opposite. So really, you just got to memorize these in a way. So here's how I remember it. You have to count to 90 before you count to 270. You see your X before you see your Y originally. So if we know that they're both switching, you have to change your X before you can change your Y. Okay? So that's just kind of a silly way that it helps me remember. So let me say it again. You count to 90 before you count to 270. Your Y and your X's are both changing. You got to change your X before you change your Y. Okay, so do what you can to help yourself memorize those rules. Okay? All right. Again, if you need to rewind the video to rewatch it, go ahead and do that. But we're going to kind of sum this up and get you some practice. All right. So now, what a rotation is. Got to know these definitions. So I appreciate your patience, but we wanted to make sure y'all see that before you actually go from here, okay? So we're going to say the rotation is actually turning the figure around a point. And in this situation, our point was the center of origin. That just says like our center of origin, so we're not moving it and then rotating it. So our center of origin was the origin itself. Again, this is going to preserve congruence. That means the shape, same size, same shape. It's just been relocated, okay? So it's the same size, same shape, it's just moving in a different direction, okay? So that flag is the same exact size, same exact shape, it's just in a different spot. We've just turned it. So this is going to be determined by degrees and by direction, like what we just summed up on that table. So we have 90 degrees, 180 degrees, 270 degrees. Sorry, that got a little messy. 270. Well, if I'm adding 90 each time, well then 270 plus 90 is actually going to be 360. And if you think about it, if we started here and did all 4 quadrants, that's 90 times 4 is 360. You're just ending up where you left off, okay? So 90 degrees is 1 quadrant. 180 is 2 quadrants. 270 is 3 quadrants. And 360 is 4 quadrants. Okay? And then the other thing is we could either, so the degrees are right here, and the directions are either going to be clockwise, which we're going this direction, and I'm just going to abbreviate that as CW, or counterclockwise, and that's going from right to left, and that's going to be CCW. Okay? So let's describe these rotations. We're going to just, and we have to read the directions because this one says right here to use the clockwise direction. So if that says clockwise, that makes a difference of what numbers we're going to use. So if I went here and I went like that with my A, does that look like it went over 1 quadrant, 2 quadrants, 3 quadrants, or 4? Hopefully you said 90. Okay? If it were to go 90, the bottom's going to be here. If we're to go again, the 180 almost looks like a reflection since that's a letter A. So something to think about. So here's my original, here's my new. If I went 90 degrees this way, then again, then one more time, we're going this way. Would that just be 1 rotation, 2 rotation, 3 rotations, or 4? Hopefully you said 3, so this is going to be 270 degrees clockwise. Okay, so you just have to kind of visualize it. So if this is my original triangle, and I rotated 1 time, and then again, this is going to be 180 degrees clockwise. So just kind of have to visualize it on that graph for you, okay? Well, here we have the same pictures, same exact pictures if you see them, but now they're counterclockwise. Well, remember, 90 degrees clockwise is the same thing as 270 degrees clockwise. So that means if I were to go rotate this letter A 3 times to the left, it would be 270 degrees counterclockwise. 270 degrees clockwise is the same thing as 90 degrees counterclockwise. So got to be careful with the direction that they want. And then 180 clockwise is the same as 180 counterclockwise. And if you haven't noticed already, 90 plus 270, 180 plus 180, 270 plus 90, all equal to 360. Okay, so if you think about it, that's something to think about and know. The clockwise direction plus the counterclockwise direction, whatever they are, equals 360 degrees. Okay? Because if you went 1 time to the right, that's the same thing as going 3 times to the left, you're going to be at that same spot. So at 90 degrees counterclockwise is the same as, well, 90 right here, 90 plus what gets you to 360 is 270. 180 plus 180 is 360. So 180 counterclockwise is the same thing as 180 clockwise. 270 degrees counterclockwise is the same as, well, 270 plus 90 is clockwise. So really, really got to do what you can to memorize these rules, because some questions might ask for a 270 degree clockwise and some questions might ask for 90 degrees counterclockwise, and they mean the same thing. So do what you can to memorize this table, and again, if you need help, rewatch this video and reach out to your teachers. That's what we're here for.